When we bring a field to the view from the data pane, Tableau creates a pill. Whether or not that pill is a dimension or a measure, or continuous or discrete, impacts every level of functionality in the analysis, from the way the data displays to the deeply technical, behind-the-scenes approach to how data is processed. Knowing the features of how Tableau works with pills is vital to staying in control of the analysis. Measures are usually metrics or numerical data, like shipping cost. Inside of Tableau, measures are aggregations. They're aggregated up to the granularity set by the dimensions in the view. The value of a measure therefore depends on the context of dimensions. For example, the result for the sum of shipping cost is dependent on if we mean overall, just under $1.5 million, or per order priority level, from 65 to about 550,000. Dimensions are usually categorical fields, such as order priority and region. Specifically in Tableau, dimensions set the granularity or the level of detail in the view. We typically want to group our data by some combination of categories. What dimensions we use to build the view will determine how many marks we have. Here we have 4 order priorities, critical to low, and we have 4 marks. We also need to consider if the pill is continuous or discrete. Continuous numbers can take on any value in a range. Discrete numbers have distinct, separate values. Most of the time, dimensions are discrete and measures are continuous. However, this isn't always true. It's possible to have numeric dimensions be continuous or to convert a measure to discrete. For example, discount is currently down here as a continuous measure. We may want to change it to discrete by right-clicking and selecting Convert to Discrete. When we hover over the pill, it's now blue, and the icon is blue as well. We can also convert it to a dimension simply by dragging it into the Dimensions area of the data pane. Note that these two operations, converting to discrete and converting to a dimension, are not synonymous. For the rest of this video, we'll mostly be talking about continuous and discrete data instead of measures and dimensions. If you're ever in doubt, remember, dimensions come out into the view as themselves, measures come out into the view as aggregates. Discrete pills are blue, and continuous pills are green. Let's start with axes and labels. When a continuous pill is brought into the view, it creates an axis. This will automatically fill the entire view along that direction. When a discrete pill is brought into the view, it creates a label with panes for each value. This will take up as much or as little room as required. Whether a pill is continuous or discrete also has an impact on default behavior for colors. A continuous pill on the color shelf will create a gradient. A discrete pill on the color shelf will create a color palette, where each unique value is assigned a color. Here I'd made a copy of my sales field and changed it to discrete, but the underlying data is identical. On a map, the default behavior depends on whether the pill is continuous or discrete, but also if it's a dimension or a measure. If the geographic type allows it, a measure on color defaults to a filled map. A dimension on color defaults to a simple map. Whether the colors are gradients or palettes depend on if the pill is continuous or discrete. Dates can be brought into the view as either continuous or discrete. If the date icon is blue in the data pane, then the default when we bring out that pill will be discrete. But if we right-click drag, we can select specifically what sort of date we want. We can change this property in the pills menu. The options at the top are discrete date parts. The lower section are continuous date truncations. Continuous date truncations are treated as an ongoing progression along an axis. Here, there's a single trend line, and December 2012 leads into January 2013. Discrete date parts are treated like categories. Each year is a different category, and there's a trend line here per year. There is a break between December of 2012 and January of 2013 because month and year are simply labels. Filtering on a discrete pill, such as category, brings up options related to the specific list of values for that pill. Filtering on a continuous measure, such as profit, first asks if we want to filter at the row level or aggregate level, then brings up options for continuous ranges. Have you ever wondered what measure names and measure values are? These are fields that Tableau automatically creates to enable certain types of analyses. Let's make a classic text table. We'll bring a dimension, like category, to the rows shelf, and another dimension, order priority, to columns, and finally, a measure, shipping cost, to text. And there we have it. But what if we want to see multiple measures instead of just one? For instance, if we want to see sales and profits for each of our regions, how would we do that? Okay, we'll bring region to rows, and sales and profit to text. This isn't what I was imagining. I wanted to have my measures next to each other, in a column each, like in Excel, not two marks in the same cell like they are here. But Tableau uses different logic than Excel, and the functionality of measure names and measure values allows for greater flexibility when dealing with different data structures. Remember with our first table, the columns were set by the dimensions, order priority, with a column for each dimension member. To break sales and profit out into their own columns, we need a dimension. That's what measure names is for. It's a dimension whose members are our measures. We'll remove sales and profit from text and bring measure names to columns. It says no measure values because measure names and measure values work hand in hand. Measure names can be thought of like the labels for the measures, so we need to have values associated with those labels. We'll bring measure values to text. By default, all measures are brought into the view, and they show up on a new Measure Values card. We can simply drag off the ones we don't want. To bring out only specific measures to a Measure Value card, we can Control-click the measures we want, along with the dimension, and then, using Show Me, select Text Table. This automatically brings out measure names and measure values to the appropriate places with just the measures we selected on the Measure Value card. Measure names and measure values are useful for more than just text tables. Here we have a line chart of sales broken out by segment. If we want to compare all the segments together on the same axis, we simply move the dimension to color. And now we have all three lines together. But what if we want to look at three measures on the same axis? We can dual axis too, but not the third. So how can we get three measures in the same line chart? With measure names and measure values. First, let's bring measure names to the filter shelf. We only want to look at sales, profit, and shipping cost. These measures all have units of dollars. It wouldn't make sense to put discount, which is a percentage, on the same axis as profit, which is dollars. Now we'll bring measure values to rows and measure names to colors. Note that we only get the three we selected in our filter, and it's three measures on the same axis. Measure names can also be used to provide labels for text tables. Here we have region on rows and sales on text. The word region appears above the regions, letting us know what these are, but there's nothing similar above the numbers. How can we easily display the field labels for the measure? If we bring out measure values and drop it on top of the sales value, measure values will replace sales on text. Measure names will automatically appear on the filter for only sales, and sales will move to the measure value card. And more to our point, the label sales appears above the column of numbers. To come full circle, if we wanted to add more measures to this table, we could simply add them to the Measure Values card. Now that we understand why Tableau is using measure names and measure values, hopefully you have a greater understanding of how to put your new skills to use when building pivot tables and controlling visualizations in Tableau. Calculating rates or ratios is a common need in Tableau. However, if we were to create these calculated fields without understanding what Tableau is doing to compute our answer, it can be very easy to get this wrong. Let's step back and go over a couple crucial concepts: granularity and aggregation. If we plot profit and sales, we only get 1 point. Tableau has aggregated the sum of sales and sum of profit and plotted that. If we want more marks in our view, we need to change the granularity, or the extent to which the view is broken down. Increasing granularity is done by adding dimensions to the view. Putting segment onto color breaks that single point into 3, a point for sum of sales by sum of profit for each segment. If we add market to size, we now have 15 marks, and there's now a point per segment for each market. Changing market to another shelf, such as shape, hasn't changed the granularity of the view. We still have 15 marks. And those 15 marks are still the sums of profit and sales for that combination of dimensions. Here, this mark is the sum of sales and sum of profit for the corporate segment for the USCA. The value of profit and sales is the aggregation that depends on the breakdown, or granularity, of the view. The detail shelf is a way of impacting the granularity of the view without encoding a field by color or size or shape. Let's see what it looks like if we put customer ID onto detail. We don't have a shape or color per customer, but our view now shows marks aggregated to the granularity of each specific combination of segment, market, and customer ID. Okay, so why do we care about all that when we're just trying to make a profit ratio? The key point for calculations is that the way Tableau calculates depends on the aggregation of the data. Therefore, it depends on the granularity of the view. Here, Tableau has summed the profits and sales for all orders in each category and presents a value for each. If we drill down to subcategory, we see the summed profits and sales per subcategory. If we expand out to row ID, we see individual records. Keeping that in mind, let's look at how to calculate a profit ratio. Here we have 2 calculated fields: profit divided by sales and sum of profit divided by sum of sales. In each case, the formula is simply what appears in the name. When we're at the record level, they give the same answer. However, when we roll back and look at our subcategory level, it starts looking really weird. Suddenly our ratios don't match, and the profit sales one here in red has huge numbers. What's happening here? When Tableau aggregates the profit divided by sales calculation to the granularity of the bar chart, it's summing the ratios themselves. A profit ratio has been calculated for each record, and those ratios have been summed. This is very different from what we want to do. By contrast, the second calculation, sum of profit divided by sum of sales, sums the profits and sales at the granularity of the view, and then takes the ratio of those 2 numbers. If we roll back further to category, the green ratio is still correct. By putting the aggregation into the calculation itself, we let Tableau know when to compute the ratio regardless of the granularity of the view. In summary, sum of profit divided by sum of sales sums the profits and sales to whatever the granularity of the view is, then computes the ratio at that aggregation. Profit divided by sales computes the profit ratio at the lowest level of granularity, then sums the ratios to the requested aggregation of the view. If we want to filter for the top 10 products by sales per region, this analysis can be interpreted two ways. Of our overall top 10 products, how do these 10 rank in each region? Or, in each region, which are the top 10 products? The first is fairly simple and is shown here. Right-clicking on the Product ID filter and selecting Edit Filter, then clicking the Top tab, we see this is the top 10 product IDs by sum of sales. But if we're trying to answer the second scenario, in each region, which are the top 10 products, we might be tempted to build the view we have here, then put Region on Filter, and select whatever region we're interested in. However, this view appears to be giving incorrect responses. Despite the fact our product ID filter says top 10 by sales, we only have 7 rows. This is a matter of how the filter is being evaluated. If you're familiar with SQL, filters are written in the where of the query clause via an AND statement. Therefore, records need to meet all criteria to be returned. For the bar chart here on top, results need to be members of the top 10 of all products by sales. And if we filter by region as well, products also need to be sold in that region. If 3 of the top 10 products are not sold in Eastern Africa, the result subset will only contain 7 products. Both conditions of top 10 and region need to be met simultaneously for a product to be returned. To filter for the top 10 products in a specific region, the setup is a little different. We need to let Tableau know that region should be considered before the top 10 is calculated. We can put the region onto a context filter, like we have with market, but that isn't very easily changed if we want to look at Northern Africa, then Western, etc. Alternatively, we can use the index calculation to assign each product an index value per region, and then we'll filter on that value. Right-click in the data pane and select Create Calculated Field. We'll name this index, and then in the formula area, we'll type index with an open and closed parentheses, and click OK. Find the new field index here in the data pane. It's currently a continuous measure. We'll right-click and select Convert to Discrete. This step is vital because we need the index values to function as labels. We'll bring this field between region and product ID in the view. Now we need to tell Tableau how to calculate the index. In other words, how we want these values to be assigned. We'll right-click on the pill and select Edit Table Calculation. We'll click Specific Dimensions, giving us complete control. Leaving region and product ID checked, we'll keep them as addressing fields. We want to do this because we need both to be considered when computing the index. We'll set at the level to product ID because we want the index values to be assigned per product ID. And we'll set restarting every to region because we want to recalculate the index assignments independently per region. Finally, we need to set the sort. We'll change it to custom and make it a descending sum of sales. Now we have our indexes properly assigned and we can filter. We edited the table calculation on this pill specifically, so we have to bring a copy of this pill to the filter shelf. We can do so by holding down the Control key while we click and drag. And we'll select just 1 through 10. Now we have the top 10 highest selling products individually per region. Similarly, we could do the same process using the table calculation rank. Right-click in the data pane and select Create Calculated Field. We'll use the rank function and have it rank on sum of sales. and we want it to be descending. We can see that what we're ranking on is very similar to how we sorted our index values. Like with index, we want to convert this value to discrete. And again, we'll bring it between region and product. Previously, we said restarting every region. Here, we'll edit the table calculation to compute using pane down. This essentially does the same thing. We can once again bring this pill to filter and choose 1 through 10. And we see that this is an alternative way to again get the top 10 products by sales per region. I hope this helps explain some of why Tableau behaves the way it does,